of QNets, and he will talk about simplifying appliances delivery and monitoring in the telco context. Stage is yours.
Good morning, everybody, and thank you for being here. And just let me tell you that the introduction, if you've followed yesterday's speech, Router Freedom in Italy in the Open Hardware track by Dario Presutti, that would have been a great introduction also to what I'm about to explain. A few words about myself. I'm currently lecturer of the cloud computing course at the University of Perugia. I'm a freelance developer and sysadmin since many years at this point. And since 2022, I'm CEO of QNets, the telco company I founded, and I'm also a member of TDF, in which I'm currently sitting and serving as a member of the membership committee. So what's a CPE? A CPE is an acronym for Customer Premises Equipment, which is what our users would normally call a router or modem. In most states, the ISPs build, maintain, and operate the network entirely from level 1, so fiber, copper, radio, whatsoever, through level 3, so IP addressing. Whereas in Italy, through years of regulatory activity by Agicom, which is the designated entity to legislate on telecommunications, a wholesale-based model has been established. So the status quo is that a few carriers build and maintain the physical infrastructure. That could be Open Fiber, FiberCop, FiberConnect, and a few others. And the retail OLOs, so those commercial entities responsible to sell the contracts to the final customers, rent the last mile access to provide the service to their users. This is a diagram by FiberCop of the various points a OLO could find himself. So the OLO is natively here, so outside of the carrier network. But on various levels, he could also find himself in the local POP, where the L1 arrives, which is normally 1, 2, 3 in a single city or metropolitan city. He could then be in the street rack, or could be entitled of managing the entire network. So OLOs have mainly two choices while renting a line. That could be either passive, so the OLO receives an L1 directly to the customers, which could be fiber, copper, or whatsoever. But this requires for the OLO to be collocated at the POP where the L1 arrives. And there he also needs to provide its own active appliances. So, for example, an optical line terminal in case of a fiber optic network. The opposite of passive service is the active service, where the OLO not just buys the termination, so the last mile, but also an Ethernet VPN to connect end-to-end its own POP, typically MIX, Namex, Topix, V6 in Italy, to the end customer. And this tunnel is entirely managed by the same carrier, so Open Fiber, FiberCop, etc. So what's the state-of-the-art provisioning flow according to network equipment manufacturers? You could either pay them an extra fee for a custom firmware with your own standard configurations. You could send, once it gets connected, to the network through proprietary protocols the configuration to the optical network terminal or another network terminal from its counterpart in the carrier's POP. Or last but not least, the CPE could acquire a TR 069.98.181 server through the HCP option 43. Why these provisioning techniques are unsuitable for us in Italy? The first one, because if you're buying less than 100,000 CPEs every month, which I guess would mean you also provision 100,000 new customers every month, it will be extremely expensive. The second one would require that both OLT and ONT are controlled by the OLO, which is trying, of course, to configure the customer premises equipment, which is not our case if we buy an active service, or couldn't be the HCP also, because on the end, the user end, it's very rare for the carrier to provide us with an untagged service, so he always terminates a VLAN also on the user end. So what could we do about that? Of course, if you don't want to use anything proprietary and if you don't want to reinvent the wheel, the only solution is to use TR069. It's based on standards by the Broadband Forum. It's almost, we'll see in a bit why, vendor independent, and as mentioned, can be advertised through the HCP. But what's an ACS, you may ask? ACS stands for Auto Configuration Server, and it's an HTTP-based service to automatically interact with CPEs, distribute configuration, firmware upgrades, run diagnostics, using TR 069.98.181. And many commercial products exist to have your own ACS, and those are normally licensed on a per device base. So you pay based on how many devices you're currently managing. And what open source products are available if you want to deploy your own ACS? Well, there's Teams ACS, but has been explicitly developed just for MikroTik devices. There's Free ACS, which is unfortunately no longer maintained. And then there's Genie ACS, which is our go-to solution. Genie ACS uses a Node.js backend and a MongoDB database, and consists of 4 different components or microservices, as you prefer to call them. The first one is the daemon that answers HTTP requests from CPEs. Then we have what would be called an API to interact with the ACS server himself. Then a file server to provide the firmware upgrades to the CPEs. And last but not least, a user interface to browse the current status of CPEs. So let's take an assumption about our provisioning flow. With these constraints, it's impossible to ship the CPE to the end customer without manual handling of every router. So it's impossible for us to buy the CPE by the manufacturer and ship it directly to the customer. We'll need to open it and configure it. But we can think how to optimize this first configuration stage. So Genie ACS is mainly organized in provisions, which are JavaScript scripts that can be executed to generate changes on the device configuration, and presets that are rules that determine when a provision is applied. What are the main issues we've encountered using Genie ACS? The relatively slow development, because the community is not yet very developed, and also it's not a product like LibreOffice that every user would use. The documentation is often too concise, and to understand many things, you either have to try them or to search on the forum. And it does often give you very, very vague errors on what's not going on. So what's a proposed semi-automated configuration flow we could adopt to speed up the CPE's configuration? We take the box, we get the router out of it, we connect it to a dedicated network in our office. In this dedicated network, the ACS URL is advertised through the HCP option 43. And after the first contact, Genie ACS starts its provisioning flow for the CPE. So checks if a firmware upgrade is due, and if so, sends it and waits for the CPE to reboot. Does a factory reset to clean the device. In this way, we can use this system also to restore CPEs that are returned from customers that are leaving us. Creates PPPoE interfaces with dedicated credentials for each of the possible VLANs that we're getting by local carriers. And finally, hands the CPE over to our production ACS so that we can monitor and configure it outside our office. Once configured, CPEs are stored in the warehouse, ready to be shipped once the customer's connection has been activated. When the CPE is shipped, the serial number of the CPE is associated to the contract. Once the CPE arrives to the customers, it will connect to the internet, and the production ACS, by querying our CRM, will be able to retrieve the production PPPoE credentials for this user, VoIP credentials, SSIDs, and other configuration, and provide the CPE with them. Also, once the CPE is configured, it will continue to send an heartbeat to the ACS every 5 minutes, which is a configurable interval. And this heartbeat will consist of an XML payload with diagnostics information like connected devices, VoIP registration status, VLAN status, and so on. What are the main problems and challenges in this operational workflow? Not every router does listen on untagged one, so if it expects a VLAN, we will have either to reconfigure the dedicated network in the office to also handle that, or log on to the management interface of the router and manually tell him, okay, go on untagged. And there are yet many vendor-specific parameters. So you will need to investigate and test the provisioning flow for every new CPE model you're acquiring. Let me get these last bits to thank Patrick, which is a person that works for us and had made a key contribution to this provisioning process. And thank you also for your attention, and I'll be available now and later for any question.
Thank you very much, Marco. We still have a minute time for questions. Is someone in the audience who's got a question? No questions. I have a question as someone that is not in the field. How do you deal with customers resetting their devices?
It's a very good question. That's one of the main issues we have. We started attaching a label on top of the reset button. The other solution would be for some carriers to save the configuration once the CPE has received it. So even if the user does a reset, it resets just the parameters that the user can configure, like the network name, and not everything else.
Okay, thank you very much.